All right, let's move on to section 2.6. With this section, we're going to start looking at graphics. So far in chapter 2, we've talked about descriptive statistics, which are numerical ways that we can summarize our data, and graphics are ways to summarize our data visually. We have to choose the type of graphic based on the type of data that we have. So this first section is a basic introduction to graphics when I have one categorical variable that I want to summarize. We'll go back to the race example from the King dataset. As a side note, the King dataset is a set of county data from several years ago from King County in the state of Washington, I believe it is, and it's looking at I think all of the pregnancies that happened in the county in that particular year to look at things like birth weight, weight gain of the mother, demographic variables of the mother and the father to see how all of those issues relate to kind of the baby's health. So when we summarize demographic data such as race, which is categorical, we want to summarize the data with either a bar plot or a pie chart. So we can use the R code here to see what the bar plot or the pie chart are going to do. So you want to jump over to AutoStat, and there's a section here, 2.6 for categorical graphics. Now the first thing I want you to notice is that if I just try to run the code chunk, if I just open up the markdown file and scroll down to 2.6, it's not going to work. Okay, I got an error. It says I can't find the object race. So the issue here is that I didn't read in my data set yet. I just tried to run the code. So I need to go back to the top of the file. Under section 2.3 is where I would have first read in the King dataset. So a couple options. I can run the entire code chunk with the play button. So let's try that. Okay, it's reading in the data, and then it's running all of my statistics that I asked for that you worked on last class. Alternatively, I could have just highlighted the row that I wanted and used run the selected lines, or this tells me the shortcut command is Control plus Enter. I use that all the time. So I'm going to hit Control Enter on my keyboard, and it's just going to run that one line and read in the data. I can see on the right-hand side in my environment here, I now have my data set read in. It shows all the variables that I have access to. Okay. And I have also created the race variable. I need to make sure to run that line as well. So that basically extracts the race variable from my data set so that I can use it by just using the word race. So now if I go back down to section 2.6, let's run this line by line to see what happens. The first line, I run a bar plot. So here's the basic picture of a bar plot. You'll see on the x-axis, I have my categorical variables. This is the way that race was recorded in this particular data set. We know that there's many other ways that we could record race, but this is what we have. And then the y-axis is the count axis, basically. So it's telling us how many observations were in that particular group. There's not a label right here, I just have the ... dots because this is showing me I can add the labels of whatever I want. So for the Y label, I might change the word to count. And for the main title, I might say bar plot of race. Okay, and if I run that again, now it's going to update with the appropriate labels that I want on my graphic. So that's a basic bar plot. It's showing me how many observations do I have in each category. And then I can also run these with a couple adaptations. Okay, so if I run this second option, we'll see that now in the code, instead of just plotting a table of counts, I'm plotting the table of proportions. So you've seen this table race divided by n previously with Dr. Canner. That's calculating proportions, and now I only want to graph them with a y-axis from 0 to 1 because proportions will never be bigger than 1. And so if I run this plot, everything looks pretty much the same. I have just changed my y-axis scale. Okay, so in this one I might want my y label to say proportion. And then I might call it bar plot of race proportions. All right, if I rerun that, there we go. Okay, so I'm going to see that the heights of the bars are the same. I've really just changed the y-axis. Okay, and then the third option is just changing this to % instead. So again, my y label could now be %. You could rerun that. And if I jump back to the notes, you'll see that these are the graphs that are shown in the plot here, where I've just changed either count, proportion, or percent. I could also color them in a rainbow way, but I'm not going to do that in the code right now because it's not really necessary. Now you'll note that in the actual packet here, I don't have a picture of a pie chart, although I have the code. And this is because it's not really suggested to use pie charts for data visualization. Even though we see them all the time, sometimes they can be really difficult to interpret. And bar charts are generally recommended as a better way to display categorical data. So we can still run the pie chart just so you can see what it looks like. Let's run that line of code in Markdown. Here's my pie chart. Here we've specified that we want the colors to be the rainbow color palette with 5 different colors, and it's labeled my categories. So the reason this isn't that great is it gets really hard to compare categories that are close in size. For example, Hispanic and Black, it's a little bit hard to tell which category is actually larger. And when we have even more categories that are closer in size, it gets more and more difficult. So bar charts are considered better practice and what you should use more generally. All right, so that's the end of basic graphics for categorical data. The message is basically use a bar plot.